So in this video, we're going to be discussing how do you write the equation of a quadratic function. So before we start, I want to begin by explaining that there are three forms that we can use. So first of all, vertex form, then intercept form, or standard form, and it depends on the information that we're given about the quadratic function. So the first form, which we have already pretty much used, is vertex form, also known as transformational form. This is what we were using when we were doing transformations. Well, the h and the k are the vertex, and it tells you the horizontal and the vertical change. So h and k would be my vertex. So we're going to use this form when we have the vertex, and it's going to be h comma k. And then also you need a point, because the point is going to help us figure out what a is. So here in this first example, we need to write the equation of the quadratic function given the point 2, 8 and the vertex 1, 2. So here this is vertex form because we have a vertex. 1 is our h, and then 2 is our k. So first of all, we're going to start by plugging in our h and our k into our formula. So we have f of x is equal to a parentheses x minus 1 squared plus 2. Now our job is to go ahead and figure out what our a value here is. So we're going to plug in our point, which this is x and this is y, right, or f of x. And so we're going to plug in our 8 here where there's an f of x, and we're going to plug in 2 here for x. And so now we're going to go ahead and simplify this and solve for a. So here when I have 2 minus 1, which is 1, 1 squared is 1. So I'm going to have a times 1 plus 2. Well, a times 1 is just a plus 2 here. And then we're going to subtract 2 from both sides so that we can solve for a. And we get that a is equal to 6. So now that I found my a, I can complete my equation here and write that the equation of this quadratic function is 6 parentheses x minus 1 squared plus 2. So if we're thinking back to transformational form, right? So the vertex here, which is 1, 2, is going to shift it to the right 1 up 2, and it's going to be a vertical stretch. Okay, so now let's go ahead and do the next example. In this next example, we're given the same information. We can obviously tell what the vertex is here. The vertex here is -1, -3. And we have a point here, which is our y-intercept of 0, -2. So first of all, we're going to go ahead and plug our vertex into our equation. So f of x is equal to a parentheses x minus -1, so that's a plus 1 squared plus -3, which is just minus 3. So again, the only one that's always going to change your sign is this h value, because it's going to be the opposite sign according to this equation. So now we're going to go ahead and plug our point of x and f of x here, which is our y-intercept. So we're going to have a -2 here for f of x, and we're going to have a 0 for x. And we're going to simplify and solve this. So we have a parentheses 1 squared, which is 1, minus 3. And so we have the equation -2 is equal to a minus 3. Add 3 to both sides. And we have that a equals 1. Now, we need to go ahead and plug that back in to here. But again, when you have multiplying by 1, we don't actually need to write that. So we're just going to write f of x is equal to parentheses x plus 1 squared minus 3. So the 1 here obviously is there, but I don't need to go ahead and write that. Okay, so now in this next example, we have a table where we're going to try to find the vertex. So again, the vertex is a changing point. So if you notice, it goes from -6 back to -6 right here. So our vertex here is this point. Some people are probably wondering, well, why does it go from 10 to 10? Well, if you notice here, it was counting by ones, and here it like skipped the number. So obviously, there would probably be a 0 somewhere here in the middle. since our quadratic is symmetrical. But anyways, this is our vertex, so this is our h, and this is our k, so I can write that f of x is equal to a parentheses x minus 0 squared plus minus 8. And then we can go ahead and pick up any point. I would suggest to pick something with a 0 in it. So here, x and our y. So we can plug in here a 0 for our y, for our output, and then a 2 for our x, and solve this out. And so 0 is going to equal to a parentheses 2 minus 0 is just 2 squared minus 8. And so here we would have 2 squared is 4, so we would have 4a minus 8. Add 8 to both sides, and you get 8 equals 4a. Divide by 4. And we get that 2 is equal to a. So our equation will look like this. F of x is equal to 2 parentheses. Again, we don't need to write that minus 0, so it's just, we can just write x squared without any parentheses, because we're not going to subtract really anything from x, so it's just x squared minus 8. So this would be just a better way to write that equation without being redundant. Okay, so now the next form that we have here is called intercept form, and in intercept form what we have are the zeros. So we're given the zeros, and again we're given a point, because in this case again we need to go ahead and we need to solve this out for a. Okay, so here it's telling me that f of negative 3 equals 0, f of 1 equals 0, and f of 2 equals 10. So these are my zeros because these are the numbers that I plug in to get a 0. So if I'm plugging it into my equation here says x minus p and x minus q. So p and q are zeros here, are the zeros. So my zeros here are negative 3 and 1. So I'm going to write an equation as a parentheses x minus negative 3. So again, here I have a minus in my equation, so it's the opposite sign, so plus 3. And then x minus 1. If you remember back to how we were solving when we were factoring, well, how would you solve for these zeros? Well, you set this equals to 0, you would get x equals negative 3. Set this equals to 0, and you would get x equals positive 1, which is obviously the zeros here. So that's why this works out. Okay, and then now we're going to use our point like we did before to figure out what a is. So we would plug in a 10 here for f of x, because that's your output, and we would plug in a 2 where would we see an x. Okay, so first order of operations, right? So we need to do my parentheses. So 2 plus 3 is 5, and 2 minus 1 is 1. If you multiply a times 5 times 1, you get 5a. You can divide this out by 5, and we get that 2 is equal to a. So now, a second. So we can go ahead and plug this back in. Instead of rewriting that, I'm just going to write that we have a 2a, a 2 as my a here. And that is the equation to this quadratic function. So here, we're given the same information. Notice that the vertex is hard to tell, so I can't use vertex form, but we're given our zeros, which is negative 2 and 1. So if I'm writing my equation, I'm going to have that f of x is equal to x minus negative 2, so plus 2. Give me a second. So we forgot to write our a there. We don't know what the a is just yet, so we're going to write an a. X plus 2. And then parentheses x minus my other 0, which is 1. We can plug in a point. So again, we're looking for a good point. So a good point right here is actually the y-intercept. We have this point would be 0, negative 3. So we have an output of negative 3. And basically what we have is zeros in here. So 0 plus 2, 0 minus 1. So this would come out to a times 2 times negative 1, which is just a is going to equal negative 2a. If you divide this both by negative 2, you get that a is going to be 3 over 2. Okay, so yes, it's a fraction, that's okay, but it is a fraction bigger than 1, so obviously it's a slight vertical stretch here. So, now, in the next example, we're given the same information. Notice that the vertex is really hard to tell because your numbers are repeating like right here, but you don't know where the changing point is. Obviously, it's negative 1.5. We're not sure about what the y value is, so we cannot use Vertex Form. Now, we do know what the zeros are, so our zeros are right here, negative 4 and 1. So we're going to go ahead and we're going to plug that into our equation. So we have f of x is equal to a parentheses x minus negative 4, so plus 4, and x minus 1. And then what we're going to go ahead and do is we're going to plug in whatever point. So again, I highly suggest choose something with a 0, so let's choose 0, 12. And so that means our output is 12, and our x's are 0. So in this case, we're going to have 12 is equal to a times 4 times negative 1. So we have negative 4a equals 12. And then divide by negative 4. And so we get negative 3 is equal to a. So we can go ahead and plug that back in here. So I'm just going to grab my eraser. Just get rid of that. And so we have negative 3 parentheses x plus 4 parentheses x minus 1. So that would be the intercept form equation. Okay, so the last type of equation that we can use is standard form. So if you remember when we were graphing, you should remember that this c value always gives you the y-intercept. So we're going to use this when we have the y-intercept and 2 points. Why 2 points? Because you need to find the a and you need to find the b here. Okay, so my y-intercept here in this equation is f of 0 equals negative 3. Remember, a y-intercept is the value of y when x is a 0. So my y-intercept is negative 3. So if I plug it into my equation, we're going to have f of x is equal to a x squared plus bx minus 3. Okay, so now what we're going to do is, well, we're going to plug in 1 point to this equation. So this is my input's negative 1, my output's 2. So we're going to put a 2 in for my output, and everywhere I see an x, I'm going to plug in a negative 1. Okay, and so 2 is going to equal to negative 1 squared is just 1, so we're going to have a. B times negative 1 is negative b minus 3. Okay. And so we're going to basically rearrange this equation so that it looks very similar, like a line, because now what you have is you have 2 variables where there's no exponent, and we're going to transform this into a line in standard form. So if I add the 3 and move it over, you get 5 is equal to a minus b. So this is one line. Now we have another point, and we can make the same thing and have 2 lines with the same variables a and b. And if you remember systems of linear equations, you know where we're going with this. So in this case, my output is, so we're going to take this same equation right here, and we're going to put an output of 3, and everywhere we see an x, we're going to put a negative 2. So we're doing the same thing, but with my other point. So my output is 3, and we have here negative 2 where we put an x. So a parentheses negative 2 squared plus b times negative 2 minus 3. Let's go ahead and simplify this. Negative 2 squared is going to be 4a. B times negative 2 is minus 2b minus 3. So what we're going to do here is we're going to, again, make this into a line in standard form because, again, our variables do not have exponents in them anymore. So we have a 2-variable equation here, which is a line. 3, and then 3 plus 3 is 6. So now I have two equations here that are lines with the same variable in standard form. We need to solve for a and b, and if you remember how to solve for this, we can do elimination. Okay, so I'm going to kind of rewrite both of my equations. So first of all, I'm going to write a minus b equals 5 and leave my c at the end. And we're going to write 4a minus 2b equals 6. And again, write it at the end here and line them up like we would do. If you remember, when we have standard form, the easiest way to solve this is using elimination. Okay, so either we can make this into a -4, or we can make this into a +2. So I think I'm going to do +2 instead. So in order to get a +2 here, I need to multiply by -2 because I need to change that sign there. And so this is going to become a -2a plus 2b, and then -2 times 5 is -10. And then here we have 4a minus 2b equals 6. And this is an equal sign. I'm sorry that kind of looks iffy there. Okay, so here are my b's. Obviously they cancel, and we're left with 4 minus 2a, which is 2a, and -10 plus 6, which is -4. We can divide this by 2, and we get that a is equal to -2. So that's my a value. And so now that I have my a value, I can plug it in to either or of my two equations here, so either this one or this one, and I can solve for b. So I can do 5 is equal to -2 minus b and solve for b. I can add 2 to both sides. And then here I get 7 is equal to -b, so b is going to equal to -7. Okay, so now let's go ahead. I have my b, I have my a value, and I had my c value from the beginning, which was -3. We can write my equation, which is f of x is equal to -2x squared minus 7x plus my y-intercept, which is -3. How would I double check this? Well, I would plug in a -1 here and make sure that I get out of 2. And I would plug in a -2 here and again make sure that I have a get out of 3. So that's how you can double check that. Alright, so I hope that you found this video helpful in how to write an equation for a quadratic function.